Welcome to Astronomy Today. I'm Dave Hostetter, curator of the planetarium at the Lafayette Science Museum, and I'll be your host. Look up at the nice clear sky sometime. They're up there. You can't see them, but they're up there. Asteroids. Asteroids are hunks of rock and metal orbiting the Sun between Mars and Jupiter, most of them in the asteroid belt. This is material that's debris left over from the formation of the solar system, stuff that never made it into the planets in the first place. Contrary to popular belief, the asteroids are not the remains of a planet that broke up or something like that. Asteroids seem to be the source of most meteorites, which are rocks from space. Many meteorites chemically match up well with asteroids, and some can even be traced to specific asteroids. Some meteorites were even observed so widely that as they fell, astronomers were able to figure out what their orbits were before they came into the Earth's atmosphere. And when we have done things like that, we find out that those orbits end up in the asteroid belt. So we've got a lot of idea that this must be something from the asteroid belt. Meteorites tell us a lot about asteroids, and they tell us a lot about the early history of the solar system. A nickel-iron meteorite like this one, for instance, tells us that some asteroids are big enough to differentiate, and that means that they are big enough to be warm enough on the inside that the heavy materials like nickel and iron sink to the center. So something like this is the remains of an asteroid that was so battered that all the rock got stripped away from the outside, and even the interior parts got battered up and broken apart too. Now, there are other types of meteorites called stony meteorites, and some of them have little rocky spheroids in them. These are called chondrules. They're very sensitive to heat, and what this tells us is that this type of a meteorite comes from a smaller asteroid that was not warm enough on the inside to differentiate. Other types of stony meteorites, though, have no chondrules. They appear to have come from rocky areas on the outside of an asteroid that at one time had melded and flowed. And there are stony iron meteorites. These seem to have come, at least some of them, from the mantles of asteroids, which are the areas between the very center and the very outer rocky crust. Because asteroids are small and far away, in most telescopes they simply look like star points. No detail, but because of meteorites, we are able to understand a lot about their structure. Not all asteroids are in the asteroid belt, though. They're not all that far away. Some of them do come past the Earth, but there are none that we know of that are on course to collide with us or anything like that, no matter what you hear on the internet. Some of these near-Earth asteroids have come close enough that we've been able to paint them with radar and get grainy images of what they look like, but we get better images when we have sent spacecraft past asteroids. But that's not as easy to do as it sounds, because it turns out that although there may be 1 million or more asteroids in the asteroid belt, it's a really big place. The width of the asteroid belt is greater than the distance from the Earth to the Sun. So it's a huge volume of space, and that means the asteroids are really far apart from each other. That makes it difficult for us to find asteroids that are near the courses of spacecraft that we send through there. Now, we have been able to do that, and we've been able to get a few pictures of asteroids, but the first really close-up images of asteroids came with the Near-Earth Asteroid Rendezvous spacecraft and the asteroid Eros. Now, Eros was orbited for about a year by that spacecraft. We studied the mineralogy and took pictures, things like that, and the spacecraft is now sitting on the asteroid Eros where it landed, even though it's not really designed to have done that. A current asteroid mission is Project Dawn. It's currently in orbit around Vesta, the third largest of the asteroids, about 300 miles across. The Project Dawn spacecraft will stay in orbit around Vesta for about a year and then go off towards Ceres, which is the largest of the asteroids, arriving there in 2015 and staying in orbit around that asteroid for a few months to finish up its mission. Now, here are two of the best pictures that have ever been taken of Ceres and Vesta from the Hubble Space Telescope. There's not much detail there. Compare them with what we see from Project Dawn around Vesta. You can see this is a very heavily cratered object, and there's a big crater down at the South Pole. A lot of geologists think that possibly the impact that caused the huge crater at the South Pole of Vesta also created certain specific kinds of meteorites that we have here on Earth. So when you're out there looking at the sky, remember, there are a lot of asteroids up there, thousands of them above the horizon at any one time. They're just too faint for you to see with anything but your mind's eye. But it's a big universe out there. Go out and take a look.